Now you can give your attendance. I repeat,
Good morning,
now
sir.
you can give your attendance. Good morning, good morning. Somnath, you haven't attended yesterday's class?
हाँ सर, मम्मी का थोड़ा तबीयत खराब है घर में, तो सर उसमें
Okay,
थोड़ा बिजी
okay.
था मैं।
Okay, but I don't know whether you will be able to understand today's class or not, because I will be continuing from where I left. So it will be better if you check the Google Classroom and see the recorded lectures.
जी सर, मैं देख लूंगा वो।
Okay,
किस
okay.
हाँ।
Okay, fine. It's 11:34 a.m. I will not waste any more time. Let us start the class. So let me present my screen first. Can anyone respond whether my slides are visible to you or not?
जी
Yes, sir.
जी।
Yes, sir. Visible.
Okay, fine. Thank you. So let me give you a brief summary of what we did in the last class. In the last class, we started solving problems related to weighted residual method, and the very first problem which we discussed was the conversion of a strong form of a given differential equation into a weak form. This problem we have seen in the last class, and then we have started the second problem. We have started this second problem in the last class, and if I recall, we have done till the calculation of domain residual, that is equation number 6. Alok, if you can respond, because you were present in the last class.
Yes, sir. We have done till equation 6.
We have done till equation number 6. Okay, so those who have went attended yesterday's class, I will request them to see the recorded lectures in the Google Classroom, because I am not explaining this problem again from the starting, because again it will take 10 to 15 minutes. So those who have joined today's class and they were absent in the last class, so please see the recorded lectures, then you will come to know. It's not that much difficult. Okay. So in the last class, we have done till equation number 6. That means for this given problem, we have calculated the domain residual. That is nothing but bx minus dx square minus 1, which is equation number 6. Now, what we need to do? We need to find out the approximate solution of the given differential equation. We need to find out the approximate solution of the given differential equation by these four methods. That is Galerkin method, least square method, collocation method. The other name is also known as point collocation method or subdomain collocation method. So let us apply the first method. So in Galerkin method, how we find out the approximate solution? In Galerkin method, we integrate the entire domain by multiplying the weighted function with the residual or the error function. Fine. Error function or residual already we have found out, that is nothing but equation number 6. The value of equation number 6 we will put in place of r. And what is my weighted function? I have told you in the very first class when I was discussing the Galerkin method that the weighted function is nothing but the assumed trial function or the trial solution. My assumed trial function was u cap a plus bx plus cx square, but I cannot take this equation number 1. Why? Because see here three unknowns are there. Fine. So after substituting different boundary conditions, when you have eliminated the value of A and C in terms of B, you use that particular trial function in place of Wi of x. That means I will use this particular trial function, that is u cap is equal to b of x minus x square by 2. Why I haven't used this trial function? Because if you use this trial function, a is unknown, b is unknown, c is unknown, you cannot solve the problem. So by the help of these given boundary conditions, what we did, we converted a and c into b. It is your choice. You can convert a and b into c. You can write a and b in terms of c, or you can write c and b in terms of a. Means two unknown values you have to write in terms of third unknown value. Here we have modified our given trial function in terms of b. So in place of weighted function, I will substitute this approximating function u cap, which is nothing but b into x minus x square by 2 into this residual function b into x minus bx square minus 1 of dx equal to 0. What will be the domain? If you see in the given problem, domain is varying from x equal to 0 to x equal to 1. So your lower limit will be 0 and your upper limit will be 1. So this is the final expression, that is integral 0 to 1. This b into x minus x square by 2 is my trial function.
सर कैन यू शो द लास्ट पेज सर? सर वो लिखे ही नहीं, समझे ही नहीं सर, लास्ट पेज।
कौन सा लास्ट पेज?
सर ये यही वाला सर,
ये तुमको मिल जाएगा, कल का जो रिकॉर्डेड लेक्चर है उसमें मिल जाएगा।
नहीं सर, ये वाला, ये जो अभी आपने दिखा रहा।
कौन सा
सर
वाला?
दिस
ये
पेज
वाला
सर,
स्लाइड?
ये जो अभी डिस्प्ले हो रहा है सर, यही वाला।
अच्छा अच्छा अच्छा।
सर एक सेकंड सर।
ओके।
अरे भाई तू बाद में लिख लेना, क्या है टाइम वेस्ट हो रहा है।
It is.
नहीं उसको
I
लिखने
will
दो, उसको
give this
लिखने दो
lecture in the Google Classroom, not an issue.
सर। गूगल क्लासरूम में फिर अगर लेक्चर करना होता फिर सर समझ में नहीं आएगा। अभी पढ़ रहे सर, अभी नहीं लिखेंगे तो फिर कैसे समझेंगे?
सर
Okay,
आप
okay,
एक काम
okay, okay,
कीजिएगा
not
ना
an
सर,
issue.
स्लाइड ही
Okay,
भेज
fine.
दीजिएगा।
Write it down, write it down. I will send the slides in the Google Classroom once the entire module is completed. Fine. And
ठीक
whenever
है
I
सर।
am taking the
जी
class,
सर।
that recorded class I will give you in the Google Classroom. But once the entire module is completed, then I will give you the slides. Otherwise, then it will be an incomplete entire module. Okay. आगे बढ़ूं? Hello.
यस सर, यस।
बढ़िया सर, बढ़िया।
Okay. 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 So this weighted function is nothing but my assumed trial function when I have written a and c in terms of unknown constant b by the use of these boundary conditions, and my domain residual is this one, equation number 6, bx minus bx square minus 1. So you multiply these two expressions, fine, and integrate it. Simple calculation is there, algebra. Fine, just integrate this entire expression after multiplication by substituting proper limits. You will get the value of b to be 5.66. After calculating or after solving this integral equation and after putting the proper limits, you will get the value of b to be 5.66. Fine. But what I need to find out? I need to find out the approximate solution for this given differential equation by Galerkin method. Already I have assumed that this is my approximating solution. U cap is equal to b into x minus x square by 2. And by Galerkin method, I got the value of b to be 5.66. So in this particular expression, I can substitute the value of b. That will be my resulting approximated solution of this given differential equation by Galerkin method. And that value, after substituting the value of b 5.66, becomes u cap is equal to 5.66 into x minus x square by 2. So this is the approximating solution of this given differential equation. When you solve this given differential equation by simple mathematics, you will get some value of u, or you will get some pattern of u. That pattern will not exactly match with the pattern of this u. It will vary. Somewhat it will vary. That's why we have introduced this error function over here. But that error will be less, very less. So this is my final solution of the
सर
given.
एक क्वेश्चन था
हाँ.
सर, ये जो सॉल्यूशन कर रहे हैं एग्जाम में
Yes.
समझेंगे कैसे कि जो कर रहे हैं वो सही तरफ जा रहा है कि गलत, क्योंकि अप्रोक्सीमेट सॉल्यूशन के लिए तो एक वैल्यू जरूरी होता है ना कि जो मेरा आंसर
See,
निकल रहा है वो
for that, what
अप्रोक्सीमेट
you
है कि
do
नहीं।
for that, if you want to validate your approximate result with the exact result, first you solve that given differential equation by mathematics.
जी
Fine. Then you have solved the given differential equation by Galerkin method. This is your approximate solution. You will get one exact solution when you solve it by mathematics. Then you compare it. For example, you draw a graph. Say your y-axis is deflection and your x-axis is distance. So your distance x is varying from 0 to 1. In between 0 to 1, you can take n number of points. Take x as 0.1. Second step, take x as 0.2. Third step, take x as 0.3. Then you find out the value of this particular u bar. For x equal to 0.1, what is your u cap? For x equal to 0.2, what is your u cap? For x equal to 0.3, what is your u cap? Till 1, you have to go. You will get some values of u cap. The same thing you have to do it in the exact solution also. At x equal to 0.1 is how much? At x equal to 0.2, how much? Till 1. You will be having both the two graphs. From that both the two graphs, you can differentiate that how much there is an error between the exact solution and the approximated solution.
ठीक है सर, ठीक है, ठीक।
Clear? Okay. So this is the final resulting solution which we got from Galerkin method. But we also need to find out the value of u of 0.5 and u of 1.0. That means what will be the approximated solution of this given differential equation when x is 0.5. U of 0.5 means value of u when x is 0.5. Value of u when x is 1. So I have the given value of u, which is u cap, approximated solution. Put x equal to 0.5, you will get the value of u. Second time, put x equal to 1, you will get the value of u cap. So for u of 0.5, the value is 2.1225, and for u of 1, the value is 2.83. Is it clear? क्या कोई doubt किसी को?
नहीं सर, क्लियर।
Okay. Next method, that is the second method by which I have to find out the approximate solution, is the least square method. And I know in least square method, I can, by the help of least square method, we can minimize this residual by which form? By the formula. See, this formula I am using. Yes, this particular formula, least square method, del partial differentiation of a constant. I told you in the, whenever I was discussing this method, I was telling you that this constant will vary from question to question. Now see, in the present question, my constant value is what? My constant, unknown constant value is b. So this partial derivative for this particular problem will be del by del of b. If you were solving this problem in terms of c, then this partial derivative would have become del by del c. If the same problem you are solving everything in terms of a, then this partial derivative will become del by del a. So for my question, I am expressing my trial function in terms of b. So this partial derivative will be del by del b of integral over the entire domain. Residual square of dx is equal to 0. So yes, del by del b of integration over the entire domain. Lower limit of the domain is 1, upper limit of the domain is u, residual square dx equal to 0. Residual already I have, that is equation number 6. you have to take the square of equation number 6 and then integrate it. After integration, take the partial derivative of that particular constant value which you need to find it out. Partial derivative of this integration. Once you solve it, then you will get the value of b to be 16.66. See the difference. When I have solved by Galerkin method, the value of b is 5.66, and when I have used this least square technique, the value of b is coming out to be 16.66. Huge difference is there. Fine. So that's why I'm telling you that all these methods will give you approximated solution nearer to your exact solution. But out of these four methods, which method will give you the best solution compared with the exact solution? For that, you have to plot that graph, what I have told you just now. Fine. So now what we will do, we will substitute this value of b in my original approximating function. Then you will get the approximated solution u cap is equal to b into x minus x square by 2, and b in this case is 16.66 into x minus x square by 2. So this is the approximating solution by least square technique. Again, I need to find out u of 0.5. That means value of u, that means value of this u cap when x is 0.5. Substitute the value of x equal to 0.5 in this expression. You will get the value of u to be 6.2475, and u of 1, that means value of u when x is equal to 1. Again, in this expression, substitute the value of x equal to 1. You will get the value of u to be 8.33. Is it clear?
जी सर इजी है.
ओके, इजी है. अभी तो मैंने इजी प्रॉब्लम कराया है इसलिए इजी है. धीरे धीरे डिफिकल्टी लेवल बढ़ाएंगे. Okay, fine. Next, the third method by which I have to get the approximating solution of the given differential equation is collocation method. The other name of collocation method is also known as point collocation method. Either you call it as collocation method or you call it as POINT, point collocation method. And in point collocation method, how we minimize the residual? We minimize the residual by equating the residual R equal to 0 at n number of collocating points. At n number of collocating points, and in the given differential equation it is very much clear that collocating point will vary from 0 to 1, because this is the maximum domain of the problem. X can go from 0 to 1. In between 0 to 1 you can take n number of collocating points. You can take n number of collocating points and you can get the approximated solution. Fine. So if that collocating point is given to you in the problem, it is fine. If it is not given to you, then it is up to you. You can divide in intervals of 2. That means you can take 0.2, 0.4, 0.6, 0.8, 1.0. 5 intervals you can take, you have taken, or else you can take 3 intervals also. But the more number of intervals you will take, you will get to know that how accurate is your solution is. So here I am not showing you all those collocating points, but I have taken one collocating point. That is, I am minimizing this residual by taking the middle collocating point. That is when x is 0.5. So when x is 0.5, I have to make this residual equal to 0. Residual means my equation number 6 equal to 0 by keeping the value of x 0.5. By keeping the value of x equal to 0.5. So b of 0.5 minus b into 0.5 square minus 1 equal to 0. By this you get the value of b to be 4. So now you have to substitute this value of b in your original approximated trial solution. That is, u bar is equal to b of x minus x square by 2. The value of b is what? Value of b is nothing but 4. So after substituting, I get the approximated solution as u cap is equal to 4 into x minus x square by 2. See, in collocating method, if I have taken the middle collocating point, I am getting the value of b is 4. Now, if I compare it with the other two process which I have did just now, in least square technique, value of b is 16.66. Okay. And in Galerkin method, value of b is 5.66. So you can say that Galerkin method and this collocating method, you are getting nearer answers. See, b is 4 in collocating method, and in Galerkin method, value of b is 5.66. But in least square method, value of b is 16.66. There is a huge deviation. Fine. So with this is your final approximating solution by collocating method. Again, you need to find out u of zero point 0.5 and u of 1. That means in this particular approximating solution, first you keep the value of x as 0 0.5. You will get u as 1.5. Then you keep x as 1.0. You will get u as 2. Is it clear?
Yes, sir.
See, this is a random guess. Randomly, I have taken x equal to 0.5. I am getting the value of b as 4. Again, you can take x equal to 0.6. The value of b gets modified. It can be 4.2, 4.3. You can take x equal to 0.8. Again, the value of b can be modified. I don't know. It can be 5 point something. So I have to get the nearer value. So in exam, see here, if I do, it will take long time. So that's why I have taken only one collocating point. But in exam, you have to verify with the other approximating method how close is your solution is. So during that time, you can take n number of collocating points. Is it clear? This third method, point collocation method, any doubt in this method?
No, sir.
Okay. Other people, please respond if you are having any kind of doubt or not.
No, sir. No, sir.
Okay, fine. Next. Next and the last method is subdomain collocation method. In this subdomain collocation method, how we are minimizing the residual? We are minimizing by taking the integral of this residual over the entire domain equal to 0. This is the method. In this subdomain collocation method, we take the entire residual, we integrate this entire residual over the complete domain of the problem, and then we equate it to 0. So residual we already have, that is nothing but equation number 6. This I will integrate it over the entire domain, and the domain value is, minimum value is 0 and the maximum value is 1. This is the residual. You integrate it. After integration, you will get the value of b is 6. Again, if you compare, see, in subdomain method, value of b is 6. In your point collocation method, it is something 4 point something it is getting, and in your Galerkin method 5 point something you are getting, and in least square method 16 point something it is getting. So as a design engineer, if you are designing, say, any beam problem which is satisfying some governing differential equation, you will not be using that least square method, because if for this problem, for this particular problem, I will not be using least square method. Why? Because that particular method is deviating. It is deviating in huge manner from the other approximated techniques. So here you are getting b as 6. You will substitute this value of 6 in your approximated solution. Your approximate solution is b into x minus x square by 2. Substitute the value of b equal to 6. So your approximated solution by this method is u cap is 6 into x minus x square by 2. Again, you need to find the value of u of 0.5 and u of 1. Substitute x equal to 0.5 and x equal to 1 in this particular expression. You will get the value of u cap, which is near about equal to u, is 2.25. And when you place the value of x at 1, you get the value of u cap as 3. Any doubt?
No, sir.
So this is a technique, this is a method how we can get the approximated सॉल्यूशन ऑफ एनी गिवन डिफरेंशियल इक्वेशन। यहाँ पे देखो, यहाँ पे जो डिफरेंशियल इक्वेशन था एक सिंपल डिफरेंशियल इक्वेशन था, लीनियर डिफरेंशियल इक्वेशन। अब इसको मैं कॉम्प्लेक्स भी कर सकता हूँ। कैसे कर सकता हूँ? d2u ओवर dx स्क्वायर प्लस sin स्क्वायर x प्लस cos स्क्वायर x माइनस 1 इक्वल टू 0। Process will be same, steps will be same. Differential equation can change from time to time. This differential equation can be d2u over dx square plus under root of u equal to under root of 1. This can also be one given differential equation. So your differential equation will vary from problem to problem, but processes or the steps will be same. ठीक है? So you can see different types of such problems from the book which I have given to you, and by this week I will give the link of 2 more books I am having. Clear है ये question? कोई doubt है किसी को?
नो सर।
Okay. So let us move towards the next problem. थोड़ा सा complicated problem. ठीक है? Third problem. Let us read the problem. What is the problem? The problem is find out the approximate solution of a simply supported beam under UDL. You can see the diagram. I am having one simply supported beam, and that simply supported beam is subjected to a UDL of intensity Q0 or Q0. As shown in the figure, the governing differential equation and the boundary condition for this problem are E into I d to the power 4 V, because here V is the unknown parameter. That means in this problem V is your deflection. V is your deflection. In the last problem, this particular term was U and the order of the differential equation was 2. Here, the differential equation is of 4th order. So E into I d4V upon dx4 minus q naught equal to 0. And the boundary conditions are V of 0 is equal to 0. That means value of V, which is the deflection, will be 0 when x is 0. Value of V will be 0 when x is equal to L, and the second derivative of x, that is d2V over dx2, is 0 when x is 0, and d2V over dx2 is 0 when L is equal to 0. Use point collocation technique and Galerkin technique to find out the approximate solution for this problem. Also use the trial function as v cap of x equal to c1 sine of pi x by L. Is the question clear? क्या क्वेश्चन में किसी को डाउट है समझने में?
नो सर।
ओके, अब
सर मुझे तो शेयर फोर्स का फंक्शन इंटीग्रेट करके निकलना
पड़ेगा, लेकिन अब इस क्वेश्चन को मैं बहुत तरीके से पूछ सकता हूँ। कैसे पूछ सकता हूँ? ये जो क्वेश्चन आपके सामने है, ये सिंपलेस्ट क्वेश्चन है। क्यों सिंपल है? बिकॉज I have given you the governing differential equation as well as the essential and natural boundary condition as well as the figure of the problem as well as the trial function. That's why ये easy है, मैंने सब कुछ दे दिया है। ऐसा भी हो सकता है कि मैं कुछ भी इंफॉर्मेशन ना दूं क्वेश्चन में। मतलब मैं कैसे पूछ सकता हूँ इस क्वेश्चन को? I can ask you this question in the other manner as find out the approximate solution of a simply supported beam which is subjected to a UDL of load intensity Q naught. Length of the beam is L. I am not giving you the figure. You have to assume, you have to think how the figure will be by point collocation technique and Galerkin technique. That means in this question, neither I have given you the differential equation, governing differential equation for this problem, nor I have given you the essential and natural boundary condition. Then how to solve the problem? अभी जो मैंने क्वेश्चन बोला, इस क्वेश्चन में मैंने खाली वर्डिंग बोला क्वेश्चन का, मैंने कहीं भी आपको ट्रायल सॉल्यूशन भी नहीं दिया, मैंने आपको डिफरेंशियल इक्वेशन के बारे में भी नहीं बोला. Neither I have told you about natural and essential boundary condition. In that case, how you will solve? In that case, if you remember some one or two lectures, some 2 3 lectures back, I have given you one table, that is this table. See, when a moment is acting in any kind of beam, then the governing differential equation is ei d2y over dx square is equal to moment for the entire cross section. When any load is acting on the beam, that load can be anything. Fine. Here, that load is UDL. So the governing differential equation is E into I d to the power 4 y upon dx to the power 4 is equal to that load. And for my question, that load will be Q naught UDL. And when shear force is acting in the beam, then the governing differential equation for the beam becomes E into I d cube y upon dx cube is equal to S, where S is the shear force. Either it can act on a part of the beam or it can act on the entire beam. So you have to remember these governing differential equation. It is not necessary that all the time I will give you the boundary condition, I will give you the governing differential equation, I will give you the trial function. If I give you, it will be easy. If I don't give you, then it will be a little bit complicated. You have to think what will be the governing differential equation. What will be the natural and essential boundary condition? What will be the assumed trial function? Then only you can solve the problem. Is the step clear? क्या समझ में आ रहा है मैं क्या बोलना चाह रहा हूँ?
यस सर।
दो तरीका है क्वेश्चन पूछने का, डायरेक्ट तरीका, इनडायरेक्ट तरीका। अभी जो मैं आपको प्रॉब्लम दिखा रहा हूं दैट इज डायरेक्ट तरीका, और जो मैंने अभी अभी बोला आपको वो इनडायरेक्ट तरीका है। फाइन। इन दैट केस अगेन यू हैव टू identify what is the boundary condition. For example, wait, let me share my whiteboard first. Can you see my whiteboard?
हाँ सर दिखाई दे रहा है।
Okay, okay. Fine. So let me wait. Okay. So say this is my beam, simply supported beam. Fine. Whether UDL is acting or point load is acting, both will be same. Means the if UDL is also acting, then also the beam will bend. If the point load is acting, then also the beam will bend. So when the beam will bend, the beam will take somewhat this kind of shape. Yes or no? Yes or no? Hello.
यस सर।
Beam will take somewhat this kind of shape. Now, by looking at this diagram, or I have to figure out what will be the boundary condition. What can be the boundary condition? Deflection is 0, and say this is x, means the beam is varying along x direction, and your overall length of the beam is L. That means I can get the boundary condition as, say, u is the deflection. U is the deflection of the beam. So value of u is 0 when x is 0. This is the essential boundary condition. Similarly, if you see, the value of deflection u will be 0 when x is L. When x is L. So this is your essential boundary condition. Likewise, you can also, from the given problem, we can see that du over dx, that is slope, again it will be 0 when x is 0. The same thing, it will be 0 when x is equal to L. Fine. See, here I have not given you the boundary condition. By the wording of the question, you have framed the diagram of the question. After framing the diagram of the question, you have determined the essential and natural boundary condition. Is it clear? कोई डाउट है?
No, sir, no doubt.
Fine. So it is not necessary that every time I will provide you, or the question will be, or I will provide you with the boundary condition. You have to read the question. Accordingly, you have to draw the diagram of the question. Accordingly, you have to decide the boundary condition. Fine. And one more thing. Every time, not necessary that the trial function will be given to you. You have to assume the trial function by drawing the proper diagram. No, now see here, I have assumed a trigonometric trial function. I haven't assumed polynomial trial function. Can anyone say why I have assumed trigonometric? Why I haven't taken polynomial trial function? That is, I haven't taken quadratic trial function. Neither I have taken cubic trial function. What is the reason behind this?
Sir, because
सर लोड यूनिफॉर्म है ना सर, तो जो मेरा इक्वेशन होना चाहिए उसका वैल्यू यूनिफॉर्म रहना चाहिए थ्रू आउट माई पीरियड.
सर
Okay.
लोड वेरी कर रहा है सर, वो कर्व में आ रहा है. U इज इक्वल टू
कहाँ
0
लोड
से.
वेरी कर रहा है
अगर
भाई?
आप देखो, अगर
भाई
आप
मैं
देखो,
बोलूं?
हेलो,
लोड
हाँ
कहाँ वेरी
यस
कर
सर.
रहा है?
हाँ, बोलो बोलो बोलो, क्या बोल रहे हो, बोलो,
सर
सुनो पड़ा.
एट U इज इक्वल टू 0 वो जीरो डिफ्लेक्शन है, और फिर U इज इक्वल टू L पे फिर जीरो डिफ्लेक्शन है. बट इन बिटवीन डिफ्लेक्शन इंक्रीज हो रहा है, मैक्सिमम हो रहा है, फिर डिक्रीज हो रहा है.
मतलब that means what you are trying to say that the deflection pattern is increasing and decreasing nature. This is say deflection u equal to 1 millimeter. Say this value of u at this particular point is 2 millimeter. This value of u is 3 millimeter maximum. Again it is decreasing. यही बोल रहे हो ना आप?
यस सर, यस सर, यही बोल.
Fine. That means अब if you divide this entire beam into n number of small element, that means मान लो ये एक एलिमेंट इतना, फिर ये दूसरा एलिमेंट, ये आपका तीसरा एलिमेंट, फोर्थ एलिमेंट, फिफ्थ. दैट मींस दिस इज एलिमेंट नंबर 1, दिस इज एलिमेंट नंबर 2, एलिमेंट नंबर 3, एलिमेंट नंबर 4, एलिमेंट नंबर 5. Fine. Now, if you try to plot this deflection curve element by element, and then you try to combine it together, you are getting this kind of curve. You are getting somewhat this kind of curve, sinusoidal curve. It cannot be cubic curve. It cannot be a quadratic curve. होगा कि नहीं होगा? क्यूबिक क्वाड्रेटिक क्या होता है?
यस सर, यस.
ऐसा हो सकता है कर्व, या फिर ऐसा हो सकता है कर्व, बट साइनोसॉइडल कर्व ऐसा होता है. कोसाइन कर्व, ये कोसाइन कर्व भी हो सकता है, साइन कर्व भी हो सकता है. ठीक है, अगर मैं इस बॉडी पे सेम प्रॉब्लम पे, अगर इस सेम प्रॉब्लम मान लो, फाइन, सेम बीम है आपका, अगर आप एक्सियल डायरेक्शन में लोड लगाते हो, तो क्या आप ट्रायल सॉल्यूशन को ट्रिग्नोमेट्रिक सॉल्यूशन एज्यूम करोगे?
नो सर, कभी नहीं.
मैं नहीं कर सकता, क्योंकि अगर आप in this same particular beam, if this P is applied along axial direction, if the same particular P is applied along axial
सर
direction,
it will be a linear equation सर.
yes, then you have to take क्वाड्रेटिक पॉलिनोमियल और क्यूबिक पॉलिनोमियल, बिकॉज वो क्यूबिक पैटर्न, क्योंकि जो डिफ्लेक्शन पैटर्न होगा उस पर्टिकुलर बीम का, वो लीनियर डायरेक्शन में वेरी करेगा. अब वो क्यूबिक भी हो सकता है, वो क्वाड्रेटिक भी हो सकता है, वो टू दी पावर फोर्थ पावर का भी क्वाड्रेटिक फोर्थ पावर का भी इक्वेशन हो सकता है, फिफ्थ पावर का भी इक्वेशन हो सकता है. इन दैट केस आई विल नॉट यूज ट्रिग्नोमेट्रिक trial function. So likewise, you can also assume, you can likewise you can guess what will be the nature of trial function if it is not given to you. So for my problem, I can say that yes, the trial function will be some sinusoidal function, some cosine function. Fine. So it can be say a into sine pi x by L, where a is a constant. It can be a into cos pi x by L. But if in the same problem you apply load in linear direction, then your trial function will be what? It will be u cap of x will be a naught plus a1x plus a2x square, quadratic function. It can be a naught plus a1x plus a2x square plus a3x cube, cubic function, and so on. क्या समझ में आया कैसे मैं ट्रायल फंक्शन सेलेक्ट करूंगा हर एक प्रॉब्लम के लिए, कैसे मैं बाउंड्री कंडीशन सेलेक्ट करूंगा हर एक प्रॉब्लम के लिए, कैसे मैं
Yes, sir. Yes.
डिफरेंशियल इक्वेशन फ्रेम करूंगा हर एक प्रॉब्लम के लिए. कोई डाउट किसी को?
Yes, sir.
No, no, sir.
Okay, fine. So the same question I can give without giving the differential equation, without giving the boundary condition, without giving this diagram, and without giving this trial function. Everything you have to assume, then you have to solve the problem. थोड़ा सा task लंबा हो जाएगा, थोड़ा tricky हो जाएगा, but it can be possible. Fine. So you need to solve such type of problems also. Okay. So for this particular problem, the given trial function is C1 into sine pi x by L. I need to solve this problem by Galerkin as well as point collocation technique. Fine. So very first step in both the method is what? Selection of trial function, which is already given. So in the problem, so the trial function v cap of x, which is near about equal to v of x, is C1 into sine of pi x by L. Equation number 1. Next is second step. In getting the approximate solution by weighted residual technique is find out the residual or the error function of the problem. How I can find out the error function? You have to evaluate the unknown parameter. In this question, the unknown parameter is V deflection by V cap. V cap will be my approximated solution. So your given differential equation becomes E into I d4 V cap upon dx4 minus q naught equal to 0. This will be your approximated differential equation for the problem. Then you can write the residual as the left part of the equation, because if this q naught is present in the right hand side, you know that how to write the residual. In order to write the residual, you have to bring everything towards the left hand side. Whatever thing is present in the right hand side, you have to bring it to the left hand side. That means you have to, if this q naught is present in the right hand side, you have to bring this q naught in the left hand side. Fine. Then the residual becomes E into I d to the power 4 v cap upon dx to the power 4 minus q naught. This is my residual. E into I d to the power 4 v cap upon dx to the power 4 minus q naught. Equation number 2. Is it clear? क्या कोई डाउट है इसमें रेसिडुअल में?
No, sir.
बाकी लोगों को कोई डाउट किसी को?
नहीं सर.
Okay, fine. Now, see, I have to find the value of this residual. How I can find it out? If I differentiate my trial function 4 times, if you differentiate your trial function, then you can get the value of d to the power d4 v cap upon dx to the power 4. Then in this domain residual, you will substitute the value of d4 v cap by dx to the power 4. That will be the resulting residual. Yes or no?
Yes, sir.
Fine. So what I will do is I will differentiate this equation 1, which is my given trial function 4 times to get the value of d4 v cap by dx to the power 4. differentiate it. Simple. That is, first time if you differentiate, differentiation of sine is cos. So C1 cos of pi x by L, then you have to use the chain rule, that is into ddx of pi x by L. So it will be C1 into pi by L will come out of the differentiation, d by dx of x is 1. So finally you are getting dv cap of dx is C1 into pi by L cos of pi x by L. Equation number 3. Is equation number 3 clear?
Yes, sir.
Simple
Yes, sir.
differentiation
Yes,
है.
sir.
Likewise, again you differentiate equation number 3. It you will get d2 v cap by dx square. That means c1 into pi by L. Differentiation of cos of pi x by L, and differentiation of cos is minus sine. So minus sine of pi x by L into chain rule d by dx of pi x by L. Pi by L again will be outside. So pi into pi will be pi square. L into L will be L square. So minus C1 pi square by L square sine of pi x by L, which is equation number 4. Likewise, again if you differentiate, you will get d cube v cap upon dx cube. Again you differentiate equation number 5, you will get the fourth order of differentiation, that is d to the power 4 v cap upon dx to the power 4, which is c1 into pi to the power 4 divided by L to the power 4 sine of pi x by L. इक्वेशन नंबर 6. क्या कोई डाउट है इक्वेशन नंबर 6 में?
No, sir. No, sir.
बाकी लोगों को कोई डाउट है इक्वेशन नंबर 6 में?
नहीं सर, नहीं.
Okay. So now I can substitute this value d to the power 4 v cap upon dx to the power 4 in my original residual equation, that is equation number 2. If you substitute this value of d4 v cap upon dx to the power 4, you will get the final resulting residual in terms of trial function, and that value after substituting you are getting it as r is equal to e into I, that is e into I into this particular value. This particular value is nothing but equation number 6, which is c1 pi to the power 4 upon L to the power 4 into sine pi x by L minus q naught. So minus q naught, equation number 7. This equation number 7 is your final domain residual or final error function in terms of your approximating function or trial function. Is it clear, equation number 7?
Yes, sir.
Okay, so I don't think the time is left. We will continue this class tomorrow. Tomorrow we are having class from 1 to 2 p.m. So after equation number 7, I will discuss in tomorrow's class. ठीक है?
Okay, sir.
Okay,
Okay, sir.
okay, fine. So I will not be discussing this problem again. So please see this problem till equation number 7. So in tomorrow's class, I will discuss from equation number 7 the rest part of the problem. After that we will solve one more problem related to heat transfer, and then we will end up this topic over here. We will be left with two more topics, that is the variational method and Rayleigh-Ritz method. After that this module number 1 will be over. Fine, then I am ending this lecture over here. If anybody is left to give his or her attendance, you can give in the chat box. Thank you.
Thank you, sir.
सर एक बात बताना था.
बोलो.
सर वो जो मतलब पोस्टर कंपटीशन हुआ था उसका तो कोई
एक
रिजल्ट ही नहीं निकला.
सेकंड, वेट, एक सेकंड.